Hello everyone, and welcome to a new live stream on the internet, where I'm going to be attempting to program Vulkan for Minecraft for Nude. Program with Vulkan, I should say. It's been a while since I've done these live streams, mostly just because I've been taking a break from programming. I've been trying to get back into it, but it's very difficult, because this is very boring and like abstract, so... It's so abstract, so it's just like, I don't get to see any of the results probably for a few more months, even. It's gonna be so fun, quote unquote, but I have faith that we can get this done, and with that, I guess let's begin. So I'm currently following a Vulkan tutorial for this backend because I don't understand how to use Vulkan, and this is just better for my purposes. Actually, I don't know if it told me what the window size would be. Oh, okay, that's not important. So what I'm working on right now is, first of all, shout out to Lightweight Java Gaming Library Game Dev on GitHub and I guess other platforms for making this tutorial. Currently working on, essentially we've gotten, I think this is where we start going 3D. However, I don't get to see any of that because, of course, I need to integrate it into the actual game engine. Because right now it's just like an abstract backends, like I said. So, a whole lot of fun. By fun, I mean that in complete air quotes. So, let's start with this. One of the harder parts of this tutorial is that I have to, first of all, my syntax is slightly different than his. Even though we're both using Java, I've chosen slightly different syntax because I think it works better, more cleanly, as well as some simple differences where, well, simple quote unquote, where I'm focusing on how to integrate this into Minecraft as opposed to him making some standalone game engine where he can just go ahead and implement things like, here's my shader file, here's my... Basically, he can get the whole pipeline working while I still have to create the backend so that then I can create the pipeline later. So, that's what I'm doing right now. And then once I do that, and I get everything maybe working, then I need to start integrating it, and might I remind everyone, even though you haven't seen it before, so might I tell you, there are 2,625 errors. There's a lot of them. Is that these new rendering techniques should vastly improve performance, and because I'm able to use multi-threaded rendering for real this time, I can actually focus on making it performant rather than just trying to squeeze blood out of turnips. So that is the hope. And then on top of that, we might get some fancy graphics, which is what I'm really hoping for, on top of the performance. Now, let's see. Let's see. What's funny is with all of this, I've actually managed to learn some stuff with lambdas. There we go. So the way I have it implemented is that each of these classes that have these things called, or have literally native resources, implementing a Java game library interface. And basically what this is that it's a thing where it just has a function called free. It's great. So the reason why I chose to have it, because each of these, so with the tutorial, one of the things it does is it has a method for every single class that has a native resource called cleanup. Only problem is that that's not a method that corresponds to an interface like native resource or like auto-closable, which means that it's just less clean because it does the exact same thing as you'd expect, except for if you, for example, put into a try, with parameters block like this, it wouldn't actually trigger the free, or it wouldn't actually free it at the bottom here. It would just insert the object. So allows us to use that, and also just it's much more convenient. We could extend an interface for the syntax. Alright, so simple thing there. Alright, let's see what happens. Or we're supposed to do next. So we're going to record command buffer, which is where I may have actually smushed that into something else because I was like, what is... I did. Okay. Okay, where's recording command buffer? There's create command buffers. That's our frame buffers. That's something different. Record vertex buffer. That's what it's called. Okay, that's not what I'm looking for though. Holy crap. Okay. So the whole point of this class, from what I can tell, is that it's supposed to handle, I mean, it's something called forward render activity. So I'd imagine it's supposed to handle the sort of broad rendering tasks. Only problem is that it appears to be a single-threaded thing. So it's gonna be, I guess this will probably be handled by the main rendering thread after all the other tasks are done. So who knows? That's the problem here. I have no idea because, of course, does it drown me out a little bit? It's like it's actually really low. Okay. Let's I guess the microphone is boosted downwards. Let's increase it a little bit. All right. 30%. I'm just not speaking terribly loudly either, so. Anyway. It's been quite a while, so I can expect errors in many facets. Alright, so the is there a submit method? And that looks, yes, okay. Record command buffer, and then it has a list of Vulkan models. This is where it gets, this is the difference. This is the difference. Forgot, okay. So, one of the main things about, isn't that like, hold on a minute. There we go. So, isn't this like precisely the same as this? Wait a minute. Yep, that's precisely the same. Okay, interesting. I don't really understand why this would be needed then. Because, well, this would be needed here, that is. Because, I have a this is essentially a mimic, of a different class called, the tessellator, which is what old Minecraft uses. However, it's mimicking in terms of it acts basically the same externally. However, internally it works a lot differently. Well, I guess it works externally, looks a little bit different, but not terribly much different. It's just a little bit more involved, so. The hell? Oh. I see. That's why it's doing that. I was like, wait, what? Master Slender TR, huh? Oh, yeah. So silly. Alright. So this is draw bind, where it binds the vertex buffer. And so, let's see, so. Right, so this draws the vertex buffer to the command buffer. Particularly not just like precisely what it is. It's drawing to the GPU in terms of it's sending the data, and then it's binding it to the command buffer that you give it. So, except for in the other case, it just uploads it in to the GPU, but with I actually don't know precisely like whether the command buffer map. Oh my god, this is not a very good cuticle cutter. So the purpose, I assume, of this is that it copies it and then it right. That's actually that's what that means. Command buffers store commands, and then you send them all at once to the GPU, which is why we have to store in a command buffer. Now, we also bind it here, because we want to, because we want to, really. I actually don't know why precisely yet, but I'd imagine it has to do with being able to use that information with shaders to actually draw objects to the screen. Now, I wouldn't, no, it's definitely not a Minecraft clone. It's a Minecraft mod. It's based off of Minecraft, but the rendering engine is completely new, because I have to. along with the input and all that nonsense. So let's see. Let's move on to the next part of the tutorial. Understand something. Understand one thing or another. Alright, so looks like that's from what I can tell. I'm trying to remember how I designed this separately to the other stuff. So I think I separated the methods, it looks like. The on new frame stuff is interesting. So of course we have our command buffers, and each one is assigned to each frame. There's one per frame. This is the global command buffer. And I'm trying to understand what's going on. I'm trying to relate this to my old OpenGL knowledge because it's the only I understand. So okay, so you can see right here, comparing the code between these two, and then this is so yeah, starts reporting commands. And then we can begin the underpass. And then we bind the light pipeline. Where's that pipeline come from otherwise? Oh, it's that. What? Excuse me? Alright, this is where mine differs from his. I don't know if it is better or worse changed, so that's fun. I feel like it might be more interesting if I bring up the tutorial on the screen for everyone to see, but then I won't be able to see the code at the same time. So I'm not sure. Anyway, so looking for beyond the frame. Depth buffer. There we go. Into consideration. Pointing to me, that's not my one. My question is, however, I feel like this is getting complicated. It's like, are these things I actually should care about? I don't know. I assume they know more about what I'm doing than I do. which is maybe a fatal flaw. So go to let's change this. It's very annoying trying to jump around like this if you're working at night. Thank you. Basically this. Except for with the current thing. And then what's the difference for? It's also for vertex buffer, right? Where's the vertex buffer? Is it here? It's not here. I don't know why it's not here, because I need it. It just allocates. This. I don't know if it's accurate. Yeah, it's confusing me because of this put pointer thing. I don't know precisely what it's doing, or whether it needs to be like you need a unique buffer every single time. For this VK command bind vertex buffers, whether you need a unique buffer every single time you bind. I would imagine so, because it's a pointer that you're binding. You're putting the pointer there in native memory. Hold on. I need to pull up this. Is there a... I think it creates a new one every time. Maybe my guess. Does it create a new one? No, it just creates... Ooh, wait a minute. It just... No, it doesn't need to be unique, because in this tutorial, they don't... They use it... They reuse the buffer. Wait a minute. No, it does not need to be unique. It just needs to be there so it can bind with the... I don't understand why that is. Am I stupid? Maybe I'm stupid. Because, yeah, it's there. They put it in a two-dimensional for loop. Interesting. I assume there's many ways to use the Vulkan architecture. You don't need to, like... Nothing about what he's doing in this tutorial, this part of the tutorial, is actually, like, hard. Like, you have to do it this way. It's an efficient way for what he's trying to do, which is load models. I don't load models because this is Minecraft. So, in the tutorial, I guess I can really show it. But he's uploading. He's using a two-dimensional for loop, which isn't really important to say that there's used more than once. We're using the same buffer more than once to then bind the command buffer to the vertex buffer. So if it's it appears to be reused, so I would assume it's supposed to be reused, which is why optimized it to where it just keeps one for like the entire time the thing is running. But let's do it this way. What is the offset? Oh yeah, that's the offset. Got it. Oh, yep. Where should I see? Wait, no. Okay. I believe that's right. Okay. So all I need to do, really, is just... boom. Now that hopefully helps solve some problems. So now I can simplify some other stuff. So I can do it here as well. So then... so now what we can do is... record a vertex data. Data. Where is it again? There we go. Simplifies things very much so. Okay. I don't understand why I would need to have a draw push method. Because yeah. It's basically the same as draw bind. Because this okay. So the reason why I don't think I need it pushes and goes to the forward runner activities because you can just get the... this should be public. Actually, I just need to... hold on. Is that correct? I think that is. Yeah, it is correct. Oh, wait. Okay. Is there anything wrong with the... okay, everything's fine. I wonder how many things. Yep, thought so. Okay. What's annoying is that I started this live stream and I realized I'd use the bathroom, so I didn't go to the bathroom. But now I need to go, so... I guess I'll just leave it here. I'm gonna come back though. Like 5 minutes. Let's go to here. This. Nope. That's not what I wanted. Okay. Enjoy Moog City, I guess. And other songs. Hello, I am back. Apologize. You know, things happen sometimes. Alright. So, let's see what's next. Alright. So let's see. So draw indexed is for pretty sure this is like yeah. Ah, okay, that makes sense now. Forgot about indexes. Okay. Wish C14 had made more Minecraft music, because I mean, this playlist is 2 hours long, but it could be longer. Just saying. And by music, I mean, like, not just ambient dribble, like the Nether and End songs. I mean, like, real, like, tunes, you know? Alright, so what is set push constants? Okay. Is this a static thing? First of all, go ahead and check. So, I believe so. Yes. So, do I do this? Yes, I do. So now what I would do is I would do yeah, okay. We'll make it separate. Yeah. Now what we're gonna do is we're gonna add a, obviously we have that, which already exists. So excuse me. Is it really this difficult? Hello? There we go. Okay. So, it is up to the creator of that data to actually handle what it wants to push with the vertex buffer. Okay. Now I'm still quite slightly there we go, confused why. Oh, I see. I see why. Okay, that's how it works. That makes a lot more sense. Okay, so the way it works, in this guy's case, is that it preloads all of the models into the GPU. At least it looks to be that way. Is that per frame? No, even per frame. No? Yeah, it's basically per frame. And then it loads the model into the GPU, and then it draws, and then for each entity, it sets push constants for that. I have a better idea. Depends on what the order is. It's the order's, is it wrong? It is wrong. That's the last thing that needs to happen. Let's work out that. check it, Mike. For the cases, because it's multiple permutations. I don't want to make it like. I guess inefficiency in this context is not that matter. By buffer, do you mean push constant buffer? Or do you mean the vertex buffer? Like which buffer? There's many different buffers. This is also the command buffer. The vertex buffer? Yeah. That's how Minecraft does it. I'm aware. Because so I'm hoping to use instance rendering for entity models, if I can. I don't know precisely if I can. I assume I can though, because the models don't change, of course, but the positions and rotations do. Yeah, push constantly a buffer. Okay, yeah, because it's like 128 bytes or something. Actually, it's a pretty decent amount of information. But I would love to be able to throw a warning if someone accidentally inputs like, yeah, probably for the mobs. I'm trying to think of other ways you could use instance rendering. I was thinking this would be big brain, and I don't know if it would work. Try to use instance rendering for each square, because so every block, of course, is a square, and how Minecraft does it traditionally is it just renders each face as such. So I'm wondering if I can just use instance rendering for each one of those squares as well, and I don't know is the answer that I've come up with. So you wouldn't want to do that? Okay, cool. I would imagine it would probably not work very well anyway. I mean, I do have a different technique that I use for optimizing the number of faces, but it'll be interesting to explore that if it's possible and performant. Alright. Let's see, what other things Minecraft would actually use that for? I guess maybe for particles? Particles might help, because those are just squares. Yeah. That's what it does. Create each individual mesh. I assume instance rendering is only for essentially copying meshes in a sense. But I don't know what parameters can be modified after it's copied. Is it just rotation and position? There is a greedy meshing algorithm that I've implemented. Now I haven't, of course, got to the point where I can re-implement could be a way of putting it, but it is as such. I might go back and revise it, could make it less, or more iterative rather than as it is currently, because it's kind of annoying. Alright. Should I go for the edge case for the... Okay. Huh. You say vertices in terms of the other stuff is a transformation on top of those vertices. Such as the translation or whatever. I'll probably make it for the push constants in the future, or like camera position or something. But okay. I guess we'll see in the future. Even for the tutorial, this game is still so confusing. Okay. Yep, 128 bytes, which is, I mean, so the main things I would probably input are XYZ coordinates, and then yaw, pitch, and maybe roll. Roll is, Minecraft doesn't use roll, but maybe we'll end up using roll. I'm not sure. Which in themselves, they're all double, so it's still only 48 bytes. So there's still a lot of room. I don't know what you would use the other bytes for, to be honest. I guess that's mostly with projection matrix. I guess you could also put the projection matrix there, but it would only be for, like, I assume whenever you're rendering to the screen as opposed to rendering to the GPU for the data upload section. Yeah. Okay, yeah. That could be what we use it for. Though I assume you can change the push constants. Is there, for push constants, is there a single instance of it on the GPU, or can it be per vertex buffer? There is 128 bytes you can tack onto it. Because it seems like in the way that this is being described, it's per vertex buffer you can do, or I guess per vertex plus index buffer in this case. You can do some push constants. So, let's see. Live inside the command buffer. Is there only one instance of the push constants inside of the command buffer? So, right here it does vk command draw indexed. Would that wipe the push constants for the next? Because that's what I would imagine it would be. Because unless this tutorial is just wrong. Actually, hold on. Do I have the ability to? I should probably just do it. Hold on. Is it? Yeah. Can you able to see this? I don't know. I'm not MC on the. Nope. That's, yep, okay, cool. So, the, also interesting how the size is different for some reason. Anyway, for each of the entities, you can see it puts in push constants, sets push constants per entity, and then it draws, for that instance. So, that's interesting. Which actually reminds me of, yeah. Actually, that means I would need to modify it. I'll create two separate algorithms for that, though. I didn't realize. I was not reading that closely enough. But it does require you to do, looks like each push constant set needs its own draw indexed call, which is interesting. If you bind a pipeline with a different push constant layout. So, is that just wrong then? Actually, I don't know if it's, hold on. If I do over here, which I can't see, if I do this and then, oh, it actually still does show. That's unfortunate. I changed monitor. But yeah. So the tutorial is just incorrect on that matter, I would assume. Has it frozen? Oh, is it? Wait, has it? Hold on. I mean, I can still see my mouse being moved. So, I'll just paste this into the IDE so it's, I guess, somewhat easy to see. I'm going to ignore all the syntax confusion here, though. So, it sets the push. This is a method that I'm not porting over because I'll just copy over the contents later. But it seems to do every time it calls an entity for the instance rendering. It's setting push constants before drawing index. 0, 9. Is it? Oh, that's because I don't have the window. I had it minimized. Sorry. It pauses the rendering on the VLC when that happens. I apologize. So, protection matrix, set push constant, model matrix, entity model matrix. That'll be. I believe this is position, rotation, and some other thing. Let's actually, I need to check. Where would that be? So, yeah, the model matrix is position, rotation, and scale. Okay. Okay. So I wanted to go back to here. There we go. So that is a valid way of doing things, to put push constants per thing. Okay. Interesting. Got it. So that means what we can do is that we can... I have an idea. Maybe this will work, maybe it won't. Let's do it this way. It repeats the same draw call every time, which is interesting. So that's an important thing to note. Because I'm lazy and don't want to have to retype everything. Also that for consistency. In case I accidentally change something, I don't mess it up for everything else. Alright, so the way we're going to do this is we're going to put a... Vulkan pipeline, and then I want a, and I'm going to want a, is that correct? Would it be better to have it, so, would it be better for each entity to be able to have its own pipeline? Or would it be better for it to just, There's two separate things I could do here. I could either do a record or I could do an interface. Interface makes more sense. Yeah. Okay. So, not precisely, because entities have different properties. Some of them, yeah, there will be there's certainly gonna be one for UI, at least for inventory UI, and then there's gonna be one for like other types of UI. So mob rendering is a bit different. Each entity applies its own shaders. There are lots of commonalities, however, some of them have their own special properties, such as glowing or transparency or the like, which I'd imagine would require different shaders to apply for that. Now, I don't know how you're supposed to apply that information precisely in that manner, but I would imagine that it would be possible to, well, I guess if there's a different shader for every single type of entity, then therefore you could essentially section off parts of the model, because it's a consistent model for the shader. I don't know if that's a great way of doing things, but I'd imagine that the so they're gonna be where an instance renderer the main problem here with using something like this is that means there'd be a consistent pipeline per. Yeah. Let's not do this way. Right. That could be, yeah. I'll leave it to where there's a pipeline per model, as in, I guess, per type of entity, but there will be it'll be common among them. I guess it really depends. I mean, like, more flexibility could mean less performance, but also could mean that we fix edge cases, and I'm a sucker for wanting to fix edge cases because I tried to push the limits of OpenGL 1.1, and it really, I guess technically OpenGL 2/1.1, and it really is meh. It's like transparency breaks half the time, which is why the game doesn't use it more extensively. Anyway, so let's see. Because, like, I can't imagine that the pipeline really is going to add. Because let's think about it this way. Quote unquote, one pipeline per mob. Really, what that could mean is many mobs share the same pipeline, as it's just inputs the same pipeline, identical reference, but one happens to have its own unique one. So we leave that option open, but the default is just this existing one. I mean, like, water's probably gonna have its own shaders, its own pipeline. Terrain's gonna have its own pipeline. Lava's gonna have its own pipeline. Glass and other translucent blocks may have their own pipeline. I'm not really sure. Depends. I'm hoping that clouds are volumetric, hoping that there's a volumetric sky, just like a very nice, pretty sky to go along with those volumetric clouds. So there's a lot I hope to do. The question is, can I at least get the game to open first? Probably. So I'm probably gonna treat all light sources as emissives. So is that all post-processing? Like all forms of light casting and shadow casting? Is that after all the generic terrain is rendered with its own terrain shader? I guess that'd be vertex shader. I think I'm understanding that, of course, since there's many steps along it, that you can have essentially nested pipelines in a sense, where a pipeline renders this object, but then you take the data from the output of that object, and then you put it into new rendering processes. That'd be my guess, but I'm probably wrong. I've done it once, not as supposed to. Okay. I'm hoping to make the shadows and lighting performant. I don't know if it will. The main reason why I say that is because the game's lighting will depend on those shadows, as in for mob spawning and stuff like that. Now, it won't be calculated the same way as the rendering, but I need to at least be visible to the player to a decent degree so that they don't get confused about why mobs are spawning, for example, in this location. So, yeah, it will be interesting. I will be using a point-based light calculation. I'll have to optimize that, of course, reading research papers, probably, to get, like, the performance I want. I don't think I'll be doing ray tracing, at least for now, mostly because I don't want to have to remake the game twice, understandably. So, anyway, so for the push data, we're gonna have this, and then a byte buffer, instance data. So the idea is that you input one bit of push data, but okay. I assume you're not the one who programs in Java. Because I don't know who makes a Vulkan game engine in Java, but you know what? I'm willing to take that honor. Assuming I can get it done. I'm hoping to get this ready for Java 21 in native time C++, yeah. I do some C# recently because Space Engineers. Maybe I don't know if you know that game, but I do some modding for it, and it was infuriating because all the syntax is like it's similar, but the way they write stuff is annoyingly different. Let's see. So set push constants. So what we're gonna do is now we're gonna do okay. This I think that's I'm worried that this is going to mess things up because it's a parameter. I wonder what other things you could have chosen. There's a lot you could have chosen. Okay, that makes me a little bit uneasy, but okay, that's fine. Instance. so make sure that's correct. Microsoft Java. Yeah. Java 21 is going to be a whole lot of fun, though. I hope, at least. They're fixing a lot of, I guess fixing is the wrong word. They're implementing a lot of long-term wanted features. So, I'm happy. And I also use Graal. I don't know if you know what that is. It's a native compiler for Java. So, hopefully, and also they're implementing a whole bunch of new things. The main thing is I have to upgrade the Java 21, so I had to get rid of old Java game library to be, well, I didn't need to, but I wanted to anyway, so I was like, kind of the final straw, because you have the security controller, sorry, which is outdated and removed, so technically deprecated to the point of not being useful, rather than actually removed and like crashes the program, but I just prefer to throw myself into the fire and hopefully get something out of it. So VK shader stage vertex bit, which I currently have highlighted. Let's see, is that? I'm using very old Minecraft to answer your question. So I do not get any of those nice benefits, but also GL3 still makes the game run really poorly, so you can barely play shaders at like 80 FPS on a 3060. Not even ray trace, just like generic rendering. It's stupid. So I'd prefer to write it myself. But Minecraft Renewed isn't just about rendering, although it has turned out to be a lot of that because Minecraft's rendering system is ancient, and that is something I wanted to upgrade. How long have I been working on rendering? Probably over a year. My guess. The calendar. Let's see. So I think that's it. I'll get byte buffer to store the information for the push constants to double loop iterated over the models. So the main key there is it uses ours uses a different byte buffer per entity, which may actually be poor. Yeah, the performance is an issue of Minecraft. But Vulkan is the future, my friend. So whenever I'm thinking like, how should I upgrade? I'm not like, let's go halfway. I'm like, no, that's stupid because I'll have to do it again. So then I go all the way. I tried going halfway and tried to make things better, and then it only made the game run twice as good. And I was like, you know what? That's not good enough. So it only runs twice as good. Let's see. So, I'm trying to think if there would be a benefit of it reads the push data into the command buffer whenever you do that, so you can reuse it. The only thing I would have to say is like, either I ask for a whole bunch of byte arrays. Oh, yep. Or what I do is I just ask for a bunch of different byte buffers. Now, because since I'm making it incredibly generic rather than the way that the tutorial does, where it just uses, since it's for entities in particular, it knows what things are being set for the push constants. However, I want mine to be generic, and as such, I've just made it towards just a generic data buffer. Now, that means we cannot reuse it, which is unfortunate. However, I don't think there's really a better option. The buffer does have to be native. So it is a downside. Because, like, how much for 8 bytes? Let's say there's like 1,000 entities. It's 128 kilobytes. That's a lot of bytes. Actually, I have a better idea. Okay. So we're gonna do byte buffer. How do they allocate it? I think it's just like a native allocation, I would assume. Because I don't want to have a bunch of natively allocated nonsense if I can do garbage collection. Push constant buffer. Okay. Stack.malloc. So we're gonna allocate. Dang it, we need to freaking use a stack. I mean, it's just one thing that I'm allocating for. So. Obviously, this is a synchronized object. There's no way you're going to use it across. Well, I'm not sure, but I hope not. Do it that way. Could either do one or the other. Permanent allocation or not. It's quite a bit alone. So, I think that would work. Also, I realize that's actually probably not the best idea. I probably should just revert back to byte buffer, because the main problem here. So, stupid Java stuff. Can't really convert between hold on. You can't convert between float array to a byte array that easily. You can hack it by doing a few separate methods. One is by using unsafe, by just changing the type of the object, or you can, which I'm not going to do because that's risky unless you know how to do it, which I don't, or you could put them into a float buffer and then read it as a byte buffer, which would do the same thing, and then you just convert it back to a byte array. So it's just a lot more complicated. So I'd rather keep it as a byte buffer and leave it open. I'd prefer to use memory as opposed to performance or CPU power because Minecraft does not use 10 gigabytes of memory. Wow. And so even if we can't optimize, great. But I would rather not sacrifice CPU for memory, at least most of the time, unless it's like marginal for massive output. Usually it's both that get, in Java, both tend to go together. But anyway, so. part of the... Yep. So, one of my questions, if you're still here, is in the command push constants here, we're using VK shader stage vertex bit. I assume... Yeah, okay, specifies the vertex stage. That answers my question, actually. Okay, yeah. Because I was concerned that maybe this is the wrong thing, but this is a vertex buffer recording, so we're fine. Now, of course, we can always do something different for if we're recording other types of things in the command buffer. The whole point of this thing is to make my life easier for later. So, if I can... So I can make my life easier for later, then precisely what I want. Alright, next thing. Now we're on to... I don't know why this is just sitting here. It's a little bit disorganized, but... Okay. Oh yeah, isn't this like something stupid? Work goes for like 50 years. Just... Yep. Okay. Make sure that we still have the submit queue. Yeah. I won't want you to get rid of multiple lines because you don't have to create a bunch of random used only once. So dumb. Alright. Public void. Hopefully it's resize. There we go. Hold on, wait a minute. You don't really need to input a swap chain in my case, because there's only one swap chain. This may change in the future, but I do have it currently set constantly. It really depends. So, I don't know what's required to make it where you can have multiple cameras. And I don't know if you need multiple swap chains, I should say, in order to make that happen. I think so, though, because swap chain is for rendering onto the screen directly, so you probably would need it for multiple cameras. However, it's not that hard to fix, to be honest. So, one per window. It's not, so let's say you have multiple cameras and you're rendering multiple, like, say you have like a TV screen, for example, in a game, and it's showing like different, like, security cameras in various rooms. You wouldn't need multiple swap chains. Like, what? It's probably too broad to ask for the moment, but what would you need? What would you need to be non-constant in order to allow you to have multiple cameras rendering onto the screen? I don't really. I mean, if that helps, that helps, you know. Because right now I have a catalog of all this, but bunch of different that's a lot of stuff. Okay, we're closing that one. It gives me a little bit of anxiety with all these errors, but resize. Oh, it's free. Right. There we go. What do you need? Why would assume it would be, you know... And then... Okay. Yeah, yeah. Got it. Okay. That's good. There's a reason why I set up... Because the way this guy set up his engine is that everything is dynamic. Oh my... Let's see, so... Let's see. There's just a bunch of stuff for like getting the set up so they can just render something to the screen to test it. I am not doing it, so. And make sure, where am I? There we go. Now I need to go back to render engine. So, what's interesting is, considering you've done this in C++, maybe you have a better grip on this. So, whenever you pull the window, so whenever you, let's see, where's the best person? Where would this be? Here we go. I'd imagine. So, whenever you pull the window events, is that done all in the same thread? Like in terms of the callbacks to our other pieces of code, thinking like, actually maybe you can't answer this question. Thinking primarily to stuff like this. Like, whenever you call back, for example, I guess in this instance it would be just for the function, whenever it's calling a function to update actions for like mouse button presses and when the windows resize and stuff like that, that's all done on the same thread as the thing that calls the pull. I guess, I don't know what else it would be, but because I have all this and I'm like I feel like they should go in the window class, but it's just not. Yeah. Okay. Well, that would then be the way it would be here, because Lowy Java Game Library, GLFW, and all these other libraries is just a front end for the library. That's all it really is, and then with some extra utilities. So if it works some way in C++, it works that way in Java. Which means that I can make it for my callback for window resize. Let's see, where would it be? Window for still resize. I'm gonna change it to where it's this, just so I can let's see, is it to be, hold on, she realized why if this is only called once I could just move it like an absolute. Okay, let's remove this. Okay, so then we do. It's already a lambda, so. So. That's what it is. There's a whole lot that needs to be changed here then, but I think it'll be good. Is there a go-to in here? Actually, I just realized the soft lock that needs to be fixed. This needs to be always here. It needs to be first and foremost. Okay. Very good that I noticed that. Otherwise, it would minimize, and then you would never be able to unminimize, which would just be top tier. Okay. Is there a pull method inside of the window? I think so. Window.pull events. Yes, that does exist. Okay, cool. Where's the VSync even set? And what is it used for? Change here. I'm trying to remember everything. Set FPS, got it. Okay. Also not using this whole thing, but very much so. So first of all, go back up here. Okay. Therefore, we can now get rid of this. First step. Second step is create a fill-in here. So. I should make moving public just to be fully editable. I realize I also set this up in the manner, but I'm not really quite sure why, creates the, let me get the handle though. Okay, there it is. And that's why it needs to recreate the window, but it will need to create it all back. That makes sense. Alright, sure. Resizing, then Full screen. Doesn't that mean we're gonna want to? Yeah. Well, the answer is yes. That is, I think that is the answer. The answer is yes. This is something we should put here. Ugh. Because wait, is it? Does this rely on anything? No, it does not. Okay. Oh, this. Main problem here is that let me read this. I may have gotten confused, but I don't think that to be the case. Called render? Alright, well, I'm gonna have to go, so hope that I can resume this at a later date. Perhaps tomorrow, who knows, maybe later today. No promises, of course. But anyway, I think I have it set up properly, but I don't know for the window resizing stuff. It's very strange. Edge cases. I'll revisit tomorrow and I'll probably something wrong and I'll have to fix it, but for now, I guess have a good day, whoever's watching, and